everyone. In this lesson, we will study the subject of vertical line test. Definition: the vertical line test must intersect with the function at only one point. If we want to know any graph, it is graph of function or not, we will draw a vertical line anywhere on the graph of the function. If the vertical line intersects with the graph of the function with more than one point, then this graph is not for the function. If the vertical line intersects with the graph of the function in only one point, then the graph it is for the function. As we see these two graphs, when we draw a vertical line here, we see that the vertical line intersects with this graph in 2 points. Then this graph is not for function. But if we see this graph, when we draw vertical line anywhere on the function, we see that the vertical line intersects with the function in only one point. Then this graph is for function. One-to-one function. What is meaning one-to-one function? A function f is from a to b is said to be one-to-one function if to each value y in the range there corresponds exactly one value for x in the domain. We can know any graph if it is one-to-one or not by drawing a horizontal line. If the horizontal line intersects with the graph in only one point, then this graph is for one-to-one function. If the horizontal line intersects with the graph in more than one point, then this graph is not for one-to-one function. As we see here, there is two values for x corresponding to this value of y. If this value of y is 1, then and this value is 3, this negative 3, then f of negative 3 is 1, f of negative 3 is 1, and f of 3 is 1, then it is not one-to-one. But this point, for any value for x, there is one value corresponding in the range. Onto function. A function f from a to b is said to be onto if its range consists of all elements of b. If the range not equal to b, then the function is not onto. If the range equal to the set b, then the function is onto. As we see in these two graphs, here the range is a and b, and the set b is also a and b, and there is no element here, not image for element in the domain. Then this function is onto. But if we see this graph, the set b is a and b, and the codomain is a, b, and c, and the element c is in the range, and it is not image for any value in the domain, then this function is not onto, since codomain is not equal to the set b. Example: which of the following is not function? We will draw vertical line in each graph and see if the vertical line intersects with the graph in more than one point, then it is not for function. Look at these vertical lines, all intersect with the graph in one point, so this graph is represent a function. If we draw a vertical line here, also we see the vertical line intersect with the graph in only one point. If we draw here vertical lines passing through any point on the graph, we see that the line intersect only with this point. But if we draw a vertical line here, we see that this line intersect with the graph in 2 points, then this graph represents not a function. Choice number D. Which of the following graph is represented one-to-one function? One-to-one function, we can know if the graph is one-to-one function or not by drawing a horizontal line. If the horizontal line intersect with the graph in 1 point, then this graph is for one-to-one function. If we see here, if we draw a horizontal line, the horizontal line intersect with the graph in 2 points, then this graph is a function, but it is not one-to-one function. Also, if we draw a horizontal line here, we see that the horizontal line intersect or passing through 3 points on this graph. Therefore, this graph is also not one-to-one. This graph is not function because it is intersect with vertical line in more than 1 point. But if we draw a horizontal line anywhere on the graph, we see that the horizontal line intersect in only 1 point, then choice number A represented a one-to-one function. Example, which one of these graphs is one-to-one function? Also, if we draw a horizontal line here, it is intersect with the graph in 2 points. If we draw a horizontal line, we see it is intersect with the graph in 2 points. Also here, if we draw a horizontal line, it will pass through 2 points, then this graph is not one-to-one, but choice B, if we draw horizontal line anywhere on the graph, it is intersect with the graph in only 1 point, then choice number B is the right choice. Which one of the following is not not one-to-one function? As we see, this graph intersect with the horizontal line in 2 points, then this graph is not one-to-one. But this graph is one-to-one. Also, this graph is one-to-one because it is intersect with the horizontal line in 1 point. Also, if we see this graph is also one-to-one, then choice number B is the right choice. Example. Write without absolute value the function f of x equal absolute value x plus absolute value x minus 2. We want to write this function without absolute value as a piecewise function. Then, the definition of absolute value function is x when x greater than or equals of 0, negative x when x less than 0, and the definition of x minus 2, it's equal to x minus 2 when x greater than or equal to minus x minus 2 when x less than 2. The joint point here should make the value inside the absolute value 0. Then, if I draw the number line here and set 0 the joint point and 2 here and distribute this function when x greater than or equals 0 here, absolute value equal to x here and here, Instead of absolute value, I can write x. When x less than 0, from negative infinity to 0, absolute value x, I can write it as negative x. For the other absolute value, when x greater than or equal to, from 2 to positive infinity, absolute value x minus 2, it's equal to x minus 2. When x less than 2, from negative infinity to 2, the absolute value equal negative x minus 2, here and here. Now, I have a piecewise function divided to 3 rows. When x less than 0, x greater than 0, less than 2, and x greater than 2. I can write greater than or equal here and less than or equal here. Now, what is the function here? It is addition of negative x and negative bracket x minus 2 minus x plus negative x minus 2 equal to minus x plus 2 equal to minus 2x plus 2 minus 2x plus 2. What is the function here? It is x plus negative x minus 2. It is x minus 2 equal to x minus x plus 2 equal to 2. Is 2. What is the function here? X greater than 2. It is x plus x minus 2. It's equal to 2x minus 2. I rewrite the function f of x without absolute value as a piecewise function. Example, write without absolute value the function f of x equal absolute value x minus 1 minus absolute value x minus 3. Rewrite x minus 1 as a piecewise function. It is x minus 1 when x greater than or equal 1. It is minus x minus 1 when x less than 1. And x minus 3 is equal to x minus 3 when x greater than or equal to 3 minus x minus 3 when x less than 3. Go to number line, set the joint point 1 and 3. For the first absolute value, when x greater than 1 to infinity, the function is x minus 1, instead of absolute value x minus 1. When x less than 1, negative infinity to 1, the function is negative bracket x minus 1. This is for the first absolute value. For the second absolute value, when x greater than 3, here 3 to infinity, the function is x minus 3. When x less than 3, from negative infinity to 3, the absolute value is equal to minus x minus 3 minus x minus 3. Now, there is a minus between these two functions. Therefore, I am going to subtract them. Minus x minus 1 minus x minus 3. Minus x plus 1 minus x plus 3 minus x plus 1 plus x minus 3, x with x negative 2, x minus 1 minus x minus 3, x minus 1 minus x plus 3, x minus 1 plus x minus 3, 2x minus 4. For the third one, x minus 1 minus x minus 3, x minus 1 minus x plus 3, x with x minus 1 plus 3, it is 2. Now, the piecewise function is equal to, we have three intervals, x less than 1, x greater than or equal 1 less than 3, x greater than or equal 3. When x less than 1, the function is negative 2. When x between 1 and 3, the function is 2x minus 4. When x greater than 3, the function is 2. This is the piecewise function. Example, complete the missing part if the domain of this function is from negative 5 to 5. Let this point here is negative 5 and this point here is 5. In both cases, if f is even and if it is odd. If f it is even, then when we change the sign of x coordinate, the sign of y coordinate it's not changed. Therefore, if we have a point here, if I take this point, then the value of the function at this point it is here, since the sign of the value not changed and the value not changed. And if I take the point here, then also the point will be here. Then the missing part will be like this, 2, 5. This is the missing part if this function is even. If the function is odd, then the value it's not changed, but the sign of the value it will be changed. If this point here it is negative a and this value here it is b and the point is negative a b and the function is odd, then the point a negative b should be also in the graph. A negative b it is here. Therefore, the graph will be like this. This is up to from negative 5 up to 5. This is the missing graph if the function is odd. Hello everyone. In this lesson, we will study the transformations of function. There is 7 main transformation for the graph of the function. The first one is y equal, if y equal f of x, then y equal f of x minus c units, then the transformation is horizontal shift c units to the right. When x is minus a number, then we have a horizontal shift c units to the left, to the right. Y equal f of x plus c, then the transformation is horizontal shift c units to the left when x when f of when y equal f of x plus a number, then we have a horizontal shift c units to the left. If y equal f of x plus c, then we have vertical shift c unit upward. If y equal f of x minus c, then we have vertical shift c units downwards. If y equal minus f of x, then we have transformation of reflection about x-axis. If y equal f of minus x negative, preceded the variable preceded by negative, then we have reflection about y-axis. And finally, y equal negative f of negative x, then we have reflection about the origin, or reflection about x-axis and y-axis. Example, use the graph to find y of y equal if y equal f of x, then find y equal minus f of x plus 6. We have two transformation here, x plus a number and the function preceded by negative. Then the first reflection is x plus a number. X plus a number, then we have 6 horizontal shift, 6 unit to the left. 6 unit to the left, 1, 2, 3. This is f. This is the origin function, f. 6 units to the left, then I have the vertex here, and I have reflection by x-axis, then the graph will be open to the down, then number D is the right choice. Y equal f of x minus 1 plus 2. Also we have two transformation here, f of x minus a number, then we have a horizontal shift 1 unit to the right, here the vertex will be, and plus 2 vertical shift 2 units upward. 2 units upward we have here. This is 1, this is 2, then the vertex is at the point 4, 2. A is the right choice. Example, if y equal f of x, then use the graph to find y equal minus f of x plus 3 minus 2. We have 3 transformation here. The first one, x plus 3, it is 3 units to the left. Then this is f. I should shift it 3 units to the left, 1, 2, 3. Then the vertex will be at negative 1, either this graph or this graph. Let me see. The second transformation, negative f of x plus 3 preceded by negative, it is reflection by x-axis, then it will be open to the down, also either this one or this one, then minus 2, it is 2 vertical shift 2 units downward, 1, 2, then the right choice is D. The second one, y equal f of minus x plus 1. We have two transformation here, minus x and plus 1. F of minus x, it is reflection by y-axis. This is F. Reflection by y-axis is this graph. Plus 1, vertical shift 1 unit upward, then it is choice A. Another example, determine if this graph is for the function f, then determine f of x plus 1. F of x plus 1, it is one transformation. It is horizontal shift 1 unit to the left. 1 unit to the left, the vertex here, negative 1, 2 should be negative 2 by 2. Negative 2 by 2, this is the needed choice B. Only this graph is shifted to the left 1 unit. Example, find y equal negative f of x minus 2 if this is the graph of f, which one is the graph of this function y equal negative f of x minus 2. This function, it contains two transformations. The first one, x minus 2, it is horizontal shift 2 units to the left, sorry, to the right, then I have the vertex here is 2, should be at 4 here. Only this graph is the right choice. Then I have negative preceded, f of x minus 2 preceded by negative. It is reflection by x-axis. Then the right choice is number C. See you next lesson.